Hi, good afternoon. My name is Dipanjan and I'm an assistant professor in EC department, also co-founder of SimYog technology. So what we do is primarily enabling Agile for hardware development. What that means is that if you're familiar with the Agile processes in software, it helps you roll out software in 3 to 6 months time frame, right? But the process is very different for hardware. Why should it take 2 years from concept to delivery of a hardware product, right? And that's what we are trying to address. If you think of the parallels, in software you do compile, the equivalent of that in hardware would be sourcing, which is a much more time consuming process. Similarly, when we test, ours is just a build and you test. In hardware you have to prototype, go to the lab, measure and test. So our mission is to enable this Agile for hardware through a simulation process. Today, these are some of the technologies that we worked through at IISc since 2012. And just to share an experience, a couple of guys from Bosch joined as PhD students and they really accelerated the process of this innovation. Right, so long story short in this is that we have some methods in matrix compression. This is a physics-based simulation, but we actually use a lot of learning from previous simulation to make the new simulation faster, and parallelization and so on. But I'll share my experiences so far. We have two products, Compliance Scope and EM Scope. Actually, Compliance Scope is the one that is actually in the market. So what does Compliance Scope do? If you look at the market segment in automotives, right, first there are the OEMs like Toyota, Volkswagen, etc. Right, when they try to make, designing the car and its functionalities, they give the order of, let's say, making the electronic components to the tier 1 suppliers like Bosch and Denso. Right, these guys have to make these products. They buy the ICs from NXP or TI, make this product, but they also have to adhere to strict compliances in terms of electromagnetic noise, right? Because when you have 50 to 100 such ECUs in a car, which you actually don't see because it's hidden, they can function well in a laboratory environment, but when you take it to the car, there's conducted noise and radiated noise, and they can malfunction. For example, this particular case, this is a Cypress test board. Cypress provides the IC for that. You press this LED or this button, this LED is supposed to glow, but in the presence of noise, it can flicker automatically, which is a false touch and it's a safety critical application. Capacitive sensor, for example, is on your dashboard everywhere in the car probably today. We did a simulation of that. You can see the correlation with measurement. What this saves the guys, the designers, is the time to market, because now they can actually run a lot of these simulations, a lot of these processes in simulation. So these are our customers. For example, with Toyota, we are working with a interesting problem of EVs, where the high voltage battery, the induction motor, and the inverter, that's causing noise and interfering with the antenna. So very interesting. So to share my experiences, it's been, I think the biggest high, as a technical guy, I get is, solving problems for our customers, right? Any of these guys, I probably can't have a conversation with them. They don't understand my language, I don't understand theirs, but through technology, solving the problems together, we actually get to connect quite a bit. Critical things what I have learned, there's always a debate about what is more important, product, market, money, etc. I think what I have come to realize, it's really the team, right? And I'm in no way saying that we are there yet. But if the team is good, then if you have a problem in the market or a problem in the product, they can identify it early and solve that, right? I think in Kumar's talk there was also a TAM which I missed. Clearly indicates we need a business person on board. Interesting observation. This I used to think, but now in my conversations with in particular Karya-san from Zuken. He said he's in Japan, right, and he has experience in US and experience in Europe. He mentioned that, I knew from before, I had a startup from US before, but he said, you're doing the right thing. Bangalore is the best place for doing a startup today. I try to justify that with this amount of investment in Bangalore, this congregation of academia, industry and government in the same place, which is probably similar to what you see in the Silicon Valley, but my personal experience has been just that the amount of money we raise runs, let's say, for 2 years, which in Silicon Valley would run for 6 months. And that gives a big advantage when you're bootstrapping or building the first product into the market. And these are some of the books that has helped. Previously, in fact, the first one is particularly interesting. Previously, I used to think that Google, Microsoft, Facebook are the ones that emerged from corridors of academia. ShoeDog is a book by Phil Knight, the founder of Nike. In fact, Nike also started as a research paper at Stanford. This is something I learned new. I was quite interested in knowing. Thank you very much.